All right, good morning or good afternoon, everyone. Uh, my name is Adlan Fela. I'm Senior Analyst with Maravedis. Welcome to today's webinar entitled 5G Fixed Wireless Industry Overview and Business Case Analysis in partnership with Siklu. This webinar follows the publication of a white paper recently published and available for download. As traditional US broadband providers are failing to provide effective and competitive broadband coverage, there is an opportunity for emerging providers to offer gigabit to the home fixed wireless access, broadband using millimeter wave spectrum and 5G-like technologies. So today we'll discuss what these technologies are and how they can be leveraged to provide unlicensed millimeter wave wireless in the US. So the agenda for today is quite dense. First, we'll present some of the key findings from the white paper, and then dive into the details of each part presented herein. Starting with the current state of broadband in the US, and actually the surprising lack of competition in many parts of the country, which affects both broadband service pricing and availability. In part two, we'll look at the current state of millimeter wave. I'm not going here to debate whether millimeter wave should be considered 5G or pre-5G or 5G-like, because really at the end of the day, what matters, at least to us, is the use cases, not the naming of technologies. I'll also make the case that millimeter wave is available today as a technology, but that the licensed millimeter wave is close guarded by the usual suspects, and therefore not available to most carriers, and therefore a licensed millimeter wave becomes a viable option. I will then pass on to Boris from Siklu to present part 3 and 4, looking at the US market potential and some business case results. Go back here. Apologies for this. There you go. Just a few words about Maravedis. We are a boutique wireless infrastructure analyst firm since 2002. And pretty much areas of coverage include the radio access networks, including macro and small cells, wireless backhaul, carrier Wi-Fi, and then increasingly 5G and IoT as all these technologies converge. And we see clearly the convergence of both technologies, RAD technologies, as well as licensed versus unlicensed spectrums. So without further delay, let's dive into some of the key findings of the white paper, which again is available for download. And I also wanted to remind everyone that this presentation is being recorded, will be available for replay, and the slide deck will be also available for download in the next 24 hours. So the first key finding here for us, I think it was a surprise for us, was that the US broadband market is still underserved. We all assume that broadband is available everywhere, and it's not the case, to the extent that the FCC 2016 Broadband Progress Report concluded that, and I quote, advanced telecommunications capability is not being deployed to all Americans in a reasonable and timely fashion. That's the number one key findings. The second important finding here is that the wireline carriers are losing customers, and they're losing them by the tons here. The latest analyst predictions were for 1 million customers lost in Q3 of this year alone across their linear platforms. And so this is also an opportunity for fixed wireless access to help these wireline carriers to regain initiative and market share. The third aspect is that fiber deployments are lagging behind. There was a lot of promise for fiber to the home services a few years back, but the reality is that fiber deployments are expensive and require a lot of time to deploy. Today, over 30 million homes are marketed with FTTH, but only about 14 million are actually connected, and we'll see why there's a gap. Another important aspect is the spectrum ownership is still in a few hands. AT&T and Verizon own about 60% of licensed millimeter wave spectrum, those putting challenged carriers not having access to that spectrum. So the result of all those trends is that we see unlicensed millimeter wave, especially in 60 gigahertz, as a viable alternative, with its 14 gigahertz of contiguous and licensed spectrum. As Boris will demonstrate, there's a case for hybrid fiber wireless. We don't think that wireless is going to solve everything, nor does fiber. And I think the two technologies can work together to solve the 21st century broadband problem. So starting here with the broadband access challenges. Oh, sorry, there is a poll here, and we want to know which part of the ecosystem do you belong to. Please take a few seconds here to answer whether you are a mobile operator, a fixed/wireline operator, a vendor, an analyst, press, or a consultant/system integrator. So we'll wait here a few more seconds as people are voting in. I'm seeing here we have quite a good bunch of fixed wireline operators, which is good news, along with some mobile operators. Okay. All right, so I think that we are getting the final votes here. Boris, if you could close the poll here, so we can get along the presentation. Okay, I'm not being able to see. I can still, we have a poll in progress here. All right, thank you. Thanks for everybody for answering. So we have a good representation of the ecosystem here, and hopefully, each part of the ecosystem will get benefit from the presentation. So we have two opposing trends going on here. On the one side, the number of connected devices, as everyone knows, in the home is exploding. And we can see in the graph on the left, research by Pew Research, that already an average of 5 connected devices per household. And that doesn't even include all the emerging wireless IoT, where we'll probably be speaking of tens of devices connected in the home. So we have more devices connected, and those devices are using more bandwidth-hungry applications such as 4K television and pretty soon virtual reality. That means the need for faster broadband. That also means that the definition of broadband is expanding beyond the 25 megabytes per second that was traditionally used in the US. So on the other side, the consumers have little or no choice when it comes to fixed broadband access. And you can see on the right-hand side graph here that the broadband internet service in the US has been plagued by uncompetitive practices. You have large nationwide ISPs having built quasi-monopolies that prohibit innovation. And they're driving down levels of service and blocking competitors. And that's according to the FCC itself. Just as an example, the FCC found that only 38% of Americans have more than one choice of broadband provider, and that doesn't really meet the standard of competition. And so that's the reason why the FCC concluded that the advanced telecommunications is not being deployed in a reasonable and timely fashion. On the other side, as I indicated earlier, compounding the issue of the ever-increasing consumer demand for broadband access, online media continues to grow in popularity, and as a result, many wireline and cable service providers are experiencing customer churn. This cord cutting is happening at a fast rate. I indicated earlier that analysts have predicting that cable, satellite, and telco operators will have lost more than 1 million customers just in Q3 alone. Just a few examples. Verizon said it lost 20,000 Fios TV users in Q3. AT&T reported losses of 251,000 customers for DirecTV, and 134,000 for UVerse. Comcast and Charter posted TV customer losses of more than 100,000 each. So on one hand, you have TV, which gives away to online subscription services, and that really needs faster and more reliable broadband internet connections. So wireline operators are hurting. As indicated, some organizations have attempted to provide a better broadband options with fiber optic. And unfortunately, that hasn't really materialized in the way it was predicted, because deploying fiber networks has just been proven to be slow and expensive, with an installation cost estimated to be about $1,000 per home. So to overcome those, the quasi-monopoly states, a new solution is required. And this figure, as you can see, there's a progression of fiber to the home services in the US. So on the top dark blue line, you can see the figures for what they call marketed homes with FTTH, which are homes that have fiber connection close by, but not actually connected with an optical network terminal and a splitter hub, etc. And so the differential here is really the last 100 meters or the last 200 meters, which is way too costly to deploy. So that gap can actually be met with fixed wireless access technologies, especially in multi-dwelling environments, as we'll see in a moment. Now moving on to the current state of millimeter wave, we have a second poll. What is the biggest obstacle to providing gigabit services today? In your opinion, is it fiber availability? Is it zoning permits? The business case is not clear enough? Time to market? Or other? I would be very interested in your responses to that important question. I will give you a few more seconds to answer here. Okay, we still have some answers coming in. We'll give everybody a chance to voice their opinion. Okay, we should probably be closing the poll. Thank you very much. All right, so in terms of the responses, a majority, 31%, believes the problem is the business case. So hopefully we'll be able to address part of that concern in the second part of the presentation today. The second most popular answer is fiber availability, which is also in line with what we're discussing today for homes connected. And then finally, we have zoning and permits, which goes beyond the technology. All right, this is very good. Moving on to current state of millimeter wave spectrum. The 5G standard is yet to be finalized. We all know that. So a 5G frequency hasn't been determined yet. However, the ITU has proposed several global viable bands in the millimeter wave spectrum. And 5G is expected to serve a large variety of use cases. In the screen here, millimeter waves, are so-called, and most people in this audience, I'm sure, know that because they have wavelengths ranging between 1 and 10 millimeters. In the context of 5G, millimeter waves are really incorporate frequencies down to about 24 gigahertz, and then everything up from there is considered millimeter wave. So focusing on the US situation, the FCC has allocated a number of millimeter wave bands, as shown in the table here. So some of them are licensed, some of them are lightly licensed, and a lot of them are unlicensed. The table differentiates these bands in more detail with a licensed V band in the top right, ranging from 57 to 71 gigahertz. This is also referred to as 60 gigahertz or V band, V as in Victor. and accounts for 14 contiguous gigahertz of unlicensed millimeter spectrum. That's plenty of spectrum there. And then we have E-band, which is 70 to 80 gigahertz, which is lightly licensed, meaning it just need to pay an administrative fee. And then there has a whole bunch of licensed bands as well. Now, the problem with the licensed band is that they are pretty much concentrated in the hands of very few players. I mentioned that Verizon, AT&T, they dominate the licensed millimeter wave spectrum with almost 60% of that spectrum. So that means that smaller ISPs are left out of this important spectrum in the 28, 39 gigahertz, for example. We know that in the US, Verizon, AT&T, they plan to deploy 5G as early as next year, and that they're conducting trials rather than commercial deployments, because radios, for example, in the 28 gigahertz, are not commercially available yet. If you have more details about who owns what in millimeter wave in the US, please refer back to the white paper. But the bottom line here is that what's left for the wireline carriers and the other ISPs is pretty much the lightly licensed and the unlicensed spectrum. The good news is that the millimeter wave research is well underway, and that has created good conditions for deployments of links in those millimeter waves. And you see here 75% year-over-year growth in the number of links registered in the US alone. Over 80 cities in the US are using millimeter wave for smart city applications. And this is an example of the current capacity record achieved in millimeter wave wireless. And the other types of organizations that are using millimeter wave are already plenty here, going from large ISPs to city authorities to private networks such as the police, LAPD in Los Angeles, all the way to neutral host service providers like Bongo. So we're making the case here that ISPs can begin offering fixed wireless access before 5G standard is officially set. Deploying 5G fixed wireless access now gives wireline operators a head start in serving new markets before more established operators can straighten their position. So there's first to market advantage here for those ISPs to take advantage of. These deployments we'll see in the second part, will take form of mixed use of technologies. And what best than an example to demonstrate what is going on already today. WebPass is a company which was acquired by Google Fiber in 2016. It is based in San Francisco. And it's an interesting example because it uses a combination of fiber and point-to-point millimeter wave radios and the lightly licensed 70, 80 plus 60 gigahertz. So WebPass was pretty much successful because it was able to offer gigabit broadband to residential and business customers. It currently operates in 8 cities. You can see the statistics for yourself. But it's very successful example here of a combination of fiber networks and point-to-point millimeter wave radios being used today to serve customers with a choice of a much higher data rates than traditional service providers can afford. Again, if you need more details about WebPass, they're available on the website. And so now I believe we are ready for hearing the market potential with Boris Mason from Siklu. Boris, the floor is yours.
Hello, thanks, Adeline. I'd like to continue here, the very left. So I'll talk about the focus on the MDU opportunity. And the reason for that is that the market is there, the demand for bandwidth is there. And the solution to provide this demand in a cost-effective way is there as well. So if we look at the general MDU opportunity or target addressable market here in the United States, there are about 100 million buildings, and about 20% of that are MDUs. So there are 1.5 million of buildings with 5 or more units in United States. So doing a simple math with the monthly fee of $70, which is the typical price for a gigabit service, and the penetration rate of 40%, multiplying this number of buildings by the average number of subscribers in those buildings, which is about 16, it results in a market potential of $8.3 billion. So it's a very big number, and we'll see later on how to address this opportunity, what is the technical solution for that. And here you can see that it is actually being deployed in the field, and these are the actual connections in San Francisco. And you can see that from January 2012, there were no millimeter wave radios installed in San Francisco area, in the city area, and it came to thousands in this year. And it's from FCC database, because the E-band spectrum is lightly licensed, so this is from a registration database, and it's not market research, it's not it's publicly available data. So our customers, service providers, use this technology to connect businesses, to connect MDUs, and they provide great service, great value. And now let's talk about the how part. So this is a typical topology for MDU connectivity, building to building. If you can see here the lines, I'll make a pointer. Right. So usually it starts from setting up the main ring, which is the solid line here, connecting those 4 buildings. The reason why most of the customers, most of the service provider use ring topology is to have protection. First of all, there is no single point of failure in this ring, and the second reason is to be flexible with where to bring the fiber from. So in this example, the fiber may be available at this building. It can be an anchor institution, or fiber can be available in this building, which is the tallest building in this area, or the fiber may be available here, which is the most cost-effective way to bring fiber, because maybe this building is a bit out of the downtown area and it costs less to bring fiber here. But the thing is that it doesn't matter where you put the fiber in this ring, because the capacity of the fiber is shared between those radios across this ring. So this is the first step. The second step is to build additional rings on top of that. So this is the secondary ring, and here may be a spur, here may be a spur. So this is the growth of this network. So usually it starts from the main ring, and then it goes to additional areas. Once again, it gives the flexibility of bringing the fiber where you want to bring the fiber to. And the second thing, it gives protection, which is really important here. For the in-building connectivity, there are several solutions. Most of the customers, they tend to utilize the existing wiring, because rewiring the building results in a significant cost. And they utilize the existing wiring, and they use G.fast. Some customers do Cat5, WebPass, they do mostly Cat5. And the radio is installed at the rooftop, it goes to the cabinet or to an aggregator which is located in the communication room. It can be copper connection, it can be fiber connection, depends on the requirements. And then from this aggregator, the signal is distributed to the units, to the living units, once again using any of the available or existing technologies, Ethernet, GFast, or even Wi-Fi. Now let's refer to the business case. And this business case is covered in the white paper published by Marvidis. And the assumption for this exercise is, first of all, the goal of the exercise is to illustrate on a particular project what the KPIs are in terms of ROI, in terms of investment needed, in terms of cash flow, etc., or building connection cost. And the assumption for this project are we are talking about project of several tens of buildings, in this case 50 buildings, with an average of 40 units per building. There is a combination of different technology, E-band and V-band. The solution is implemented using a resilient topology with the ARPU of and the average revenue per user is about $75, and the take rate is 40%. So I'll refer to the interactive business case tool that we've developed, and here's the link. Once you get the presentation, you can go there and use it on your own. So this is how the tool looks like. The KPIs are here, and everything is calculated online instantly. The assumptions regarding the wireless infrastructure are here. The assumptions regarding the in-building connectivity are here, and the business case parameters here. Now, we are talking about 50 sites. The topology overhead is 10%. It means that there are additional 5 links needed in order to provide this resilient ring topology. The installation cost is $1,500, and the assumption here is that we talk about a bulk project. So those 50 units are not connected as a unit here, unit there. Those 50 sites are not connected as a site here, site there, but as a project. Now, with the in this project, we assume that 80% will be E-band radios and 20% will be V-band radios. These are some indicative costs for volume pricing that we assume here. For in-building connectivity, we use a switch for $1,000 with 10 ports, for example. So it means that for a unit of 40 buildings, for a building of 40 units, we'll need 4 switches. The installation cost is 3 hours. The CPE cost is $50, etc. For the business parameters, there are 40 units in the building. The ARPU is $75. The take rate is 40%, and the operational efficiency is 80%. Now, if we'd like to do some sensitivity analysis, which is really simple here, for example, under these assumptions, the ROI of this project is 10 months, and the cost of building connected is about six grand. The cost for apartment connected, this includes the infrastructure part as well as the in-building connectivity, is about $600. For example, if we double the installation cost to $3,000, it will not result significantly in the ROI. However, if we reduce the take rate, for example, for 30%, it will add about 3 months to the ROI. Or if we'll increase the number of units in the building to, let's say, 100 units, it will decrease significantly the ROI. So you can see here what is important for this business case to work. The business parameters are here has they have a more significant effect on the business case. Okay, so once again, this tool is available, and you can use it and play with the numbers. Another use case for this technology is what we call complexes, campuses, industrial parks, garden-style apartments. So there is another layer of the technology that is used here, which is the point-to-multipoint V-band. So how does it work? One of the buildings, so we talk here about a complex that is composed of several buildings, and the operator intends to bring connectivity to all those buildings, and maybe some common areas and some additional applications like connecting cameras or providing Wi-Fi, etc. So the main building is connected using fiber, where the fiber is available, or the fiber is extended using point-to-point E-band. And all smaller buildings are connected using point-to-multipoint V-band. And for in-building connectivity, the same solution as G.fast or Cat5 is used as discussed earlier. So the building blocks are for the backhaul fiber where it is available, or E-band point-to-point radio. For the drop, for the connectivity of those small buildings, the most cost-effective, the fastest solution is the point-to-multipoint V-band. And for the in-building connectivity, it can be G.fast, Ethernet, Wi-Fi. So this solution is particularly interesting in complexes, campuses, or even industrial parks with the several buildings located in nearby. And this solution can provide connectivity to all of them. We have a solution for single-family homes in the same, pretty much the same topology, the same manner as we serve a garden style. So the E-band, the fiber is extended to the neighborhood and then distributed into neighborhood using point-to-multipoint. And the terminal unit of the point-to-multipoint is connected to the residential gateway. We'll not go into the details of the business case here. The business case is described in the white paper. You can see the outcomes, the KPI, and contact us if you would like to get more details. Now, a couple of words about Siklu. We are a millimeter wave company, and we are a world leader in this space with more than 50,000 units deployed in more than 30 countries. Though United States is our largest market, and here is a snapshot of registered radios. Once again, E-band is lightly licensed band, and it should be registered in the FCC database. So this information is actually the actual deployments, the actual registrations of different E-band vendors. And as we may see, in 2017, we were about 50%. And we are leading the market for the 5 years. So anywhere 50 to 60%, these are take rates. This is the market here in the United States. There are more millimeter wave use cases than we covered here in this webinar. We've talked about gigabit to the home and campus connectivity, and maybe the MDU connectivity can be also the same solution applies for the business broadband, but there are additional use cases. There are some related to smart city, the Wi-Fi backhaul, small cell backhaul, and video surveillance. And this is actually the fastest growing market, the fastest growing vertical in the company from what we see. And there are also mobile backhaul, connecting towers, etc. So this solution, this equipment, this tool can be used for additional use cases. We have a complete millimeter wave offering. So we have E-band radios. Most of the use cases of those radios are rooftop or tower connectivity because of the form factor. We have 1 foot and 2 feet flavors, a solution that can go up to 10 gigabit per second for distances up to 2.5, 3 miles. In the middle, this radio is designed for street level connectivity, so it provides up to 1 gig aggregated capacity. It's a small box with a lot of bells and whistles for camera connectivity, for PoE out, PoE in, camera connectivity, small cells, Wi-Fi. Once again, 1 gigabit aggregated capacity for about 0.6 miles, 6 by 6 inches box, blends at the street level. And this one is the point-to-multipoint radio. This is a new product. We released that in April. So far, more than 2,000 units deployed here in the United States. It provides up to 1.8 gigabit aggregated capacity. A single base station covers 90 degrees sector and can talk to 8 clients. So this solution is for distribution, street level, and single family homes. We also provide planning tools. So we developed planning tool to automate the planning and the deployment process of those radios. It can take into account LiDAR data. It can calculate line of sight. It can come up with the network, with an optimal network topology and some of the trade-offs between the cost and coverage, etc. Generate report, generate performance, generate bill of material. Very useful. So we launched this in beta trials with some friendly customers, and we are going to release this for the public in Q1 next year. Back to you, Adlan.
Okay, thank you. I just unmuted myself. Thank you very much, Boris, and again, apologies for all the technical troubles here. The conclusions of both presentations is that pre-standard 5G is a way to get a head start over established carriers. And we've seen that on one hand, there's a high concentration of spectrum in the licensed millimeter wave. And on the other hand, we've seen that the deployments of fiber-only FTTH is not a very viable cost economical solution, and therefore the mixed use of fiber and wireless can be an economical solution to provide a broadband at a fraction of the cost. And again, for the details of the business model, business tool, available in the white paper. And if you want to go beyond the white paper and actually run your own numbers, because every scenario deployment is different, then I invite you to contact Boris. The link to download the white paper is presented here and available. I would like to remind that yes, the webinar has been recorded and it will be edited to fit into a shorter session. And the slides deck will also be available for download. And so that concludes this webinar, but I would like to actually start the Q&A portion of the webinar. We have some questions from the audience for you, Boris. Perhaps you want to run the next slide just to make sure people have your contact information handy as they look at the responses to their questions. So this is my contact information if you need market research or content marketing in the wireless industry. And the next slide is Boris' contact information. But the first question here we have is what are the most important lessons you have learned in all of your millimeter wave deployments?
Well, I think that the most important thing is to understand the advantages, but also understand the limitations of this technology. As we've discussed, the main advantage of this technology is huge capacity, the capability of providing huge capacity, but the limiting factor is line of sight and also limited distance. So it can provide interference-free capacity in very dense deployment, as we shown in the San Francisco slide. But you also need to understand how to plan the network, how to take into account rain attenuation. The good thing, though, is that there are models that are available in industry standard models that take into account rain attenuation, and we have link budget tool to do so as well, and not to stretch too much this technology. I mean, not the E-band, for example, is suitable for, let's say, up to 2.5 miles, 3 miles in some regions, but it won't work as a standalone technology, as a standalone radio for longer distances. And this is a very important point. Now, when the network is planned correctly in terms of availability calculation, in terms of the distances, the service provider that will deploy that will achieve fiber-like availability. So we have service providers that guarantee 4 nines or 4.5 nines and even 5 nines.
Okay. Okay. Great. Another question, and that's a concern that or comment that I have heard more than once, and that is, why not just using licensed instead of unlicensed, since there's plenty of lightly licensed.
Yeah. So there are several licensed technologies. So when you refer to licensed frequencies, you may think about microwave, or you may think about millimeter wave. So the disadvantage of licensed microwave is usually the channels are very narrow. The coordination process, in particular in dense environments, even in suburban environments, is cumbersome, and there are also a lot of radios that are being installed, so there are no channels available at some geographies. So this is comparing to licensed microwave. And for licensed millimeter wave, there is a license needed, and you just heard about Verizon that bought Straight Path for more than $3 billion. So it's not really the licensed millimeter wave is not really an option for most of the service providers.
Okay, all right. I have a question here, also from the audience, that want to know if your ROI calculator includes labor, and
yeah.
Where would licensing be required?
Yes. So the license cost for the lightly licensed spectrum, which is E-band, is $75 per 10 years, which is $7.50 per link per year, which is really negligible. It includes labor. There are some assumptions about installation costs as well as in-building connectivity costs. You can play with the numbers and you can plug in your numbers. The main thing to keep in mind about the labor cost assumptions is when you deploy. If you're a service provider and you deploy it by yourself, then probably the costs are pretty accurate. If you hire a subcontractor and ask him to deploy a single link, probably it will cost you much more. Therefore, the assumption there is to work at the project kind of approach. So instead of asking a subcontractor to install a single link, you need to go with the 10 or 20 buildings. Then the cost to install radio at the rooftop, at the building, and the particular building in this project approach will be much less than for a single radio.
Excellent. Okay, we have more questions coming in, and the next one is: can the V-band point-to-multipoint function in non-line of sight mode, I guess?
Yeah. So yeah, that's an interesting question. In general, all the frequencies, and this is a physical property, right? All the frequencies starting from higher than 6 gigahertz require line of sight. Though in some conditions, V-band, the 60 gigahertz, can function in non-line of sight or near line of sight conditions. When we talk not about penetration of walls or penetration of trees, but about refractions. So we have some deployments for that as well. That being said, it's not the common practice. So most of the deployments are within the line of sight.
Okay. Great. I see a lot of questions more about technology than business model here. So I mean, it probably talks about the type of audience we have. Is Siklu using Wi-Fi-like technology over the air interface in that 60 gigahertz?
So we use, I assume that what is the background technology in our V-band products? This is the question? Yeah. So for the point-to-point radios, we use our own developed technology. For the point-to-multipoint radios, for the radio part and for the baseband, we use off-the-shelf WiGig technology. And the benefit of using WiGig technology that it can really drive the costs down, because WiGig is really consumer grade or consumer type of technology in terms of the cost, because it was intended to go to the headsets and laptops, etc. And it enables to build very cost-effective solutions. And our secret sauce is to take this consumer kind of technology and make it carrier-grade outdoor product.
Right. Okay. So you're taking advantage of the, some of the bill of materials cost savings from consumer grade, and then add some of your secret sauce to it.
Yep.
Okay. I think we have time for one final question here before the end of the webinar. This one is okay. I'm going to try to read this one very slowly for you. For redundancy and ring rooftop topologies, are you relying on L2 spanning tree to obtain loop-free topology? Or is there something you're doing within the radius to obtain a loop-free path?
Yeah, so it's a great question. For a ring topology, we implement ERP, which is the layer 2 protocol, Ethernet ring protection, and it is actually implemented inside our radios. So there is no need in additional gear or any additional equipment to support this protocol. Everything is implemented in the ODU, in the radio, and all the switching, all the redundant path, and all the corrections that are needed, or loop prevention, is actually embedded into the software that comes with the radio. We have some customers that, and our radios are layer 2 devices, and we have some customers that they deploy, they implement layer 3 protocols over those networks, but our radios are layer 2.
Okay. All right. Well, this is all, folks, for today's webinar. In case we haven't responded to your question, the Siklu team will do follow-up with you. I want to thank you, the audience, for participating today, and apologies for some of the technical troubles. The presentation and the recording will be available next, I'm hoping to say 24 hours. If not, we'll keep you posted. And thank you again, Siklu, for collaborating and helping us with this webinar. And thank you, Boris, and thanks for everyone involved. Have a great rest of the day.
Thank you. Thank you, everyone. Thank you, Adlan.
Thank you.